This video is about understanding the relationship between sides of a right triangle and the trigonometric ratios. So we have three trig functions that we are going to look at: sine, cosine, and tangent. So when we look at a triangle, it has to be a right triangle, and the other two angles can be one of the reference angles. So in this case, angle D is our reference angle. Based off the reference angle, you can label your sides. So across from the reference angle is the opposite leg, across from the right angle is the hypotenuse, and the third side is the adjacent leg. Depending on your ratios then, are going to set up using those sides. So sine is going to be your opposite over your hypotenuse. Cosine is the adjacent over your hypotenuse. And tangent is the opposite side over the adjacent. So based on the side lengths, you can set up a fraction depending on which trig ratio you are looking for. So number one, we want to determine the trig ratio and reduce all ratios. So before we can do the trig ratio in number one, we need to know the missing side. So we can do Pythagorean theorem. 15 squared equals 9 squared plus x squared. 225 equals 81 plus x squared. 144 equals x squared. So the missing side is 12. So now we have two possibilities that we could use for reference angles, D or F. We can never use the right angle as the reference angle, just the other two. So based off of angle D, our opposite side across would be the 9, our hypotenuse would be the 15, and then the third side, which is next to the angle, our adjacent side, is 12. So if I want the ratio of the sine of D, that's the opposite over the hypotenuse. So we have 9 over 15, which reduces to 3/5. Cosine is the adjacent over the hypotenuse. So we have 12 over 15, which reduces to 4/5. And then the tangent of angle D is the opposite over the adjacent, which would be 9 over 12, which reduces to 3/4. When you switch your reference angle, so now that we're looking at angle F, our hypotenuse is going to stay the same, but now across from F is 12, so that is our opposite, and next to F is 9, which is now our adjacent. So the sine of F, opposite over hypotenuse, 12 over 15, which is 4/5. The cosine of F, which is adjacent over hypotenuse, is 9 over 15, which reduces to 3/5. And the tangent is the opposite over the adjacent, which is 12 over 9, which reduces to 4/3. So notice if you're looking between the two columns, your sine and cosine are going to switch, and your tangent is going to be the reciprocal of each other. So let's look at another triangle. So this time we are missing the hypotenuse. So we have x squared equals 4 squared plus 2 squared. X squared equals 20. So x is the square root of 20, which simplifies to 2√5. So first we're going to start with our reference angle of G. So based off of G, we have opposite, hypotenuse, and adjacent. So our sine, which is opposite over hypotenuse, is 2 over 2√5, and we have to rationalize. So we get 2√5 over 10, which would be √5 over 5. Our cosine of angle G is adjacent over hypotenuse. So we have 4 over 2√5. Again, we need to rationalize. So we get 4√5 over 10, which is going to simplify to 2√5 over 5. And then we have our tangent, which is opposite over adjacent, 2 over 4, which reduces to 1/2. When we switch our reference angle to angle H, the opposite and the adjacent switch. but the hypotenuse stays the same. So our sine of h is opposite over adjacent, which is 4 over 2 root 5, which we already know from before will simplify to 2 root 5 over 5. Our cosine of h is adjacent over hypotenuse, which is 2 over 2 root 5, which will simplify to root 5 over 5. And then our tangent is the opposite over adjacent, so 4 over 2, which reduces to 2 over 1, or just 2. In number 4, we want to find the sine of angle C. Now, when you're finding the sine of angle C, you have to use the right triangle, so we're going to use that extended dot triangle. When we're doing sine of angle C, it is the opposite over the hypotenuse. We don't know the opposite side yet, so we're going to do Pythagorean theorem. 17 squared equals 8 squared plus x squared. 289 is equal to 64 plus x squared. 225 is equal to x squared, so x is 15. So if I'm looking at the full right triangle then, my opposite side of C is 15, and my hypotenuse is 24. In number 5, to find the sine of A, we first need to draw in the altitude to split that base in half. So now we can find the altitude by doing Pythagorean theorem. 24 squared equals 10 squared plus x squared. 576 equals 100 plus x squared. 476 equals x squared. So we get the square root of 476, which simplifies to 2 root 19. 2 root 119. So now we can focus on one of these triangles. And if we are doing the sine of angle A, that is the opposite side, which is the 2 root 119 over the hypotenuse, which is 24. So this simplifies to the square root of 119 over 12. In number 6, find the ratio. So in a 45, 45, 90 triangle, remember we have L root 2. So if I want the sine of 45, that is the opposite over the hypotenuse. So our opposite side is L over L root 2, which would get us 1 over 1 root 2. And then we can rationalize to get root 2 over 2. The cosine of 45, adjacent over hypotenuse. Well, the adjacent side's also L, and the hypotenuse is L root 2, so this one is actually going to reduce to the same fraction of root 2 over 2. And then the tangent of 45 is the opposite over the adjacent, so L over L. That simplifies to 1 over 1. In number 7, given the ratio and a function, determine what angle. So given sine, we have 20, which would be the opposite, and 29, which would be the adjacent. So the opposite side of 20 would be angle R. For the tangent, we have opposite over adjacent. So if this is my opposite and my adjacent, the opposite side of 21 is angle A. So that would be the tan of A. And then for the cosine, adjacent over hypotenuse. So 29 is the hypotenuse, and 20 is the adjacent side, which is next to angle A, so it is the cosine of A. Given the right triangle, which of the following is equal to B over A? So we want to look at which ratio would give us this. So the sine of A would be opposite over hypotenuse, which would be A over, and we don't have this, so we'll call this C, not what we're looking for. The sine is also not going to work because, again, it's using that side we don't want, so we can eliminate both signs right away. So now the tangent of A or the tangent of B. Well, remember that B would need to be the opposite, and A would need to be the adjacent. So the opposite side of little b is capital B, So this is representing the tangent of B. In our last type of problems, we are given a trig ratio and we want to find another ratio. So what's going to happen is we are going to draw a right triangle, and the angle it gives us we're going to put in the bottom corner. So now cosine is adjacent over hypotenuse. So if I have my opposite, my hypotenuse, and my adjacent, the hypotenuse is 37 and the adjacent side is 12. We want to find the sine of P, which is opposite over hypotenuse. So we need to know the opposite side. So first we're going to do Pythagorean theorem. So when we do Pythagorean theorem, we get 1,369 equals 144 plus x squared. 1,225 equals x squared. So when we take the square root, we get x is 35. So now we can fill in our ratio. So our opposite side is 35 and our adjacent side, or our hypotenuse, is 37. In number 9, given triangle tug. So we have if the tangent of angle G, so we're going to put G in the corner. Tangent is your opposite over your adjacent. So if we label our triangle with our sides, the opposite is 3, the adjacent is 4. And we want to find the cosine of G, which would be the adjacent over the hypotenuse. Right now we don't know the hypotenuse, so we're going to do Pythagorean theorem. X squared equals 3 squared plus 4 squared. X squared equals 25. So the hypotenuse is 5. So our adjacent over hypotenuse, the adjacent is 4, and the hypotenuse is 5. In number 10, given triangle big, if the sine of B, so when we draw our triangle, we have the angle B. Sine is your opposite over hypotenuse. So we know the opposite is 7, the hypotenuse is 24. We want to find the tangent of B, which is opposite over adjacent. So we're going to have to do Pythagorean theorem to get the adjacent side. 25 squared equals 7 squared plus x squared. X squared equals 576. So x is 24. So we have our opposite side 7 over our adjacent side 24.